There are millions of stars out there in the universe, and just like you, they come in all sizes and masses. We have brown dwarfs, and we have lots of stars like our own sun. We have red giants and supermassive giants. We also have some very small stars, white dwarfs and neutron stars. And these are the stars that happen at the end of the life cycle of some stars. Now, to get to a black hole, these are the really massive stars. These are stars that are 10 times the mass of the sun. And it's those stars that go on and die to become black holes. We're going to hand over to Annika now, who actually studies black holes, to tell us a little bit more about what goes on inside them.
What are black holes? Black holes are some of the most fascinating objects in the universe. They are so massive, dense, and the gravity is so large that all of its mass is concentrated at a single point. They have a virtual surface, or more or less like a one-way membrane, where matter can just flow in. This virtual boundary of the black hole is termed as an event horizon. Once matter is in, it just can't escape out. Even if something is traveling at the speed of light, it just can't escape out from the event horizon or from the inside of a black hole. We don't get to see anything coming out of it. So how do we learn about these structures? This is when accretion disk comes into the picture. All what we've known of, all what we've learned of black holes have been deduced from the study of accretion disks. And these structures, they are formed when you have a blob of gas or a matter from a neighboring star, and as it is moving somewhere near the black hole, because of the huge gravity of the black hole, it pulls in matter from the star and it's going to form a disk-like structure. So you have the matter from this star, which is moving in, orbiting around the gravitating black hole, the central black hole, I would say. And as it spirals around, it chooses to follow a smaller orbit. So it spirals inwards, and eventually falling into the black hole. So these accretion disks are literally the feeding ground for the black holes. And in terms of mass, black holes can be categorized into two: stellar massive black holes and supermassive black holes. Stellar massive black holes are formed from the collapse of a star, and they are a few times the mass of the sun, say from 5 to 20 times the mass of the sun. And the second category, which are supermassive black holes, these are monsters with a huge appetite residing at the center of every galaxy. Even our own galaxy, the Milky Way, hosts a supermassive black hole by the name Sagittarius A. And these are formed when you have two galaxies merging together. And they are a billion times the mass of the sun. Very, very massive structures. Some of the most interesting aspects on the study of black holes that's happening now is with the discovery of gravitational waves. So similarly, if you have like massive objects like black holes or binary black holes, if you have these structures in the space, they create similar waves like the ones seen on the surface of water. And these are termed as gravitational waves, which can be detected. Now, these gravitational waves helps us in learning. It takes us all the way back to the time when the universe itself was born, from the Big Bang. Well, by learning black holes and accretion disks, we get to know how these exotic structures are growing, how the galaxies are evolving, and in that way, how the universe itself is growing every second. So in one way, we get to know about our own existence from a basic and in the most fundamental manner by learning these structures.